Watch this. A fully playable game with smooth controls, collision detection, scoring system, and particle effects. Looks pretty good, right? Here's the kicker. I built this entire thing in just 30 minutes. No game engines, no fancy frameworks, just pure JavaScript and HTML5 Canvas. And by the end of this video, you'll know exactly how to build it too. 30 minutes stopwatch, 1 game, 0 excuses. The challenge. I've coded hundreds of projects, and the biggest lie in programming is that you need to spend months learning before you can build something cool. That's garbage. The secret? Start with something small, timebox it, and actually finish it. Today, we're building a game called Dodge Master. Simple concept. Control a character, dodge falling obstacles, rack up points. But here's what makes this tutorial different. We're doing it fast, and I'm showing you every single line of code. First, we need our HTML foundation. This is dead simple, just a canvas element where our game will live, and script tags to load our JavaScript. The canvas is our drawing board where everything magical happens. HTML structure with viewport meta tag for responsive design. Canvas element with ID game canvas as the game rendering surface. Inline CSS styling including flexbox centering. Gradient background from purple to violet. White border with rounded corners on canvas. Box shadow for depth effect. And external JavaScript file game.js linked at bottom of body for game logic. Now here's where it gets fun. We initialize our canvas, set it to 800 by 600 pixels, and grab the 2D rendering context. This context is our paintbrush. Every shape, line, and color goes through it. We also set up our GameState object to track everything. Player position, obstacles, score, and whether the game is running. Here's our game foundation. We're grabbing the canvas, setting dimensions, and creating our game state. The player starts at the bottom center. We have an empty obstacles array that will fill, and game running is false until we press start. JavaScript game initialization starting with canvas and context references. GameState object contains player properties including X and Y coordinates set to bottom center of canvas, width and height of 40 pixels, movement speed of 5 pixels per frame, and bright green color. Obstacles array starts empty and will be populated during gameplay. Score starts at 0. Game running Boolean controls game loop execution. Spawn timer tracks frames for obstacle spawning. Spawn interval set to 60 frames between spawns. Input handling uses keys object to track pressed keys, with key down event setting key to true and key up setting to false for smooth movement control. We're making great progress. We've set up our foundation, and now we're moving into the fun stuff, making things move and interact. Each step builds on the last, and before you know it, we'll have a complete game running. Player movement. Movement is crucial. We check if arrow keys are pressed, move the player, and clamp the position so they can't escape the canvas. Left arrow decreases X, right arrow increases X. The math.max and math.min keep the player inside bounds. Move player function handles player movement and boundary checking. Arrow left key checks if X coordinate is greater than 0, then subtracts player speed from X to move left. Arrow right key checks if X plus width is less than canvas width, then add speed to move right. Optional arrow up checks Y is greater than 0 and subtracts speed to move up. Arrow down checks Y plus height is less than canvas height and add speed to move down. Math.max and math.min clamp X coordinate between 0 and canvas width minus player width. Same clamping applied to Y coordinate between 0 and canvas height minus player height to prevent player from moving outside canvas boundaries. See the difference? Without boundary checking, the player can fly off screen. With it, smooth movement that feels professional. Now we spawn obstacles. Every 60 frames, we create a new obstacle at a random X position at the top of the screen. Each obstacle has position, size, speed, and a random color. We push it into our obstacles array. Spawn obstacle function manages enemy creation. Spawn timer increments each frame. When spawn timer reaches spawn interval of 60 frames, new obstacle object is created. Obstacle X position uses math.random multiplied by canvas width minus 40 for random horizontal placement. Y position starts at -40 to appear above screen. Width and height both 40 pixels. Speed randomized between 2 and 4 using 2 plus math.random times 2. Color uses HSL format with random hue from 0 to 360 degrees, 70% saturation, and 50% lightness for vibrant random colors. Obstacle pushed into obstacles array. Spawn timer resets to 0. Spawn interval decreases by 0.5 each spawn with math.max ensuring minimum of 30 frames for increasing difficulty. Update obstacles function loops through obstacles array backwards to safely remove items. Each obstacle Y coordinate increases by its speed value to move downward. If obstacle Y exceeds canvas height, it's removed with splice and score increases by 10 points as reward for successfully dodging. Watch how obstacles spawn randomly at the top and fall down. Each one has its own speed and color. As the game progresses, they spawn faster. This creates that addictive escalating difficulty. Collision detection sounds scary, but it's actually simple geometry. We check if two rectangles overlap. If the player's box intersects with an obstacle's box, that's a collision. Game over. This is the collision algorithm. For each obstacle, we check if it overlaps with the player using ABB collision detection. If any obstacle collides, game over. We also add a cool death animation with particles. Check collisions function implements ABB collision detection algorithm. Loops through each obstacle in obstacles array. Collision condition checks 4 overlap cases. Player left edge less than obstacle right edge. Player right edge greater than obstacle left edge. Player top edge less than obstacle bottom edge. And player bottom edge greater than obstacle top edge. All 4 conditions true means rectangles overlap indicating collision. When collision detected, game over function called and function returns true. If no collisions found returns false. Game over function sets game running to false stopping game loop. Create particles function called with player center coordinates for explosion visual effect. Semi-transparent black rectangle drawn over entire canvas with fill style RABA 0, 0, 0, 0.7 for dimming effect. White text displays game over message in bold 48px Arial font centered horizontally using text align center. Final score displayed in 32px font below game over message using template literal to show score value. Instruction text in 20px font tells player to press space to restart position below score. All text rendering uses center alignment at half canvas width for proper positioning. Boom! When the player hits an obstacle, we get a satisfying explosion of particles, the screen dims, and the game over screen appears with the final score. This is what makes it feel like a real game. Let's add juice. Particles make everything better. When the player dies, we create 30 particles that fly out in all directions. Each particle has velocity, gravity, and fades out over time. This is the polish that separates amateur from pro. Particle system creates explosion effects. Particles array stores all active particles. Create particles function takes X and Y coordinates for spawn location. Loop creates 30 particles at explosion point. Each particle object contains X and Y position matching spawn coordinates. Vx velocity calculated as math.random minus 0.5 times 10 giving range from -5 to +5 for horizontal spread. Vy velocity uses same formula for vertical spread. Life property starts at 1 representing full alpha opacity. Decay value of 0.02 controls fade speed. Color uses HSL with random hue between 15 and 75 degrees creating orange to red spectrum with 100% saturation and 50% lightness. Update particles function loops backwards through particles array. Each particle X increases by Vx velocity for horizontal movement. Y increases by Vy for vertical movement. Vy increases by 0.3 each frame simulating gravity pulling particles down. Life decreases by decay value creating fade-out effect. Particles with life less than or equal to 0 removed with splice. Draw particles function renders each particle. Global alpha set to particle life value for transparency effect. Fill style uses particle color. Fill rect draws 4 by 4 pixel square centered on particle position by subtracting 2 from x and y coordinates. Global alpha reset to 1 after drawing to prevent affecting other rendering. The difference is night and day. Without particles, collisions feel bland and unrewarding. With particles, every death feels satisfying and visually interesting. This is game feel. Finally, our game loop. This runs 60 times per second, updating everything, checking collisions, and drawing to the canvas. This is the heartbeat of our game, the function that brings everything to life. Drawing functions render game visuals. DrawPlayer function sets fill style to player color and draws filled rectangle at player coordinates with player width and height. White stroke added with stroke style and 2 pixel line width using stroke rect for outline effect. Draw obstacles loops through obstacles array, sets fill style to each obstacle color, and draws rectangle at obstacle position. Draw score displays score in white bold 24px Arial font aligned left, positioned at coordinates 20, 40 using template literal to show current score value. Game loop is main game function running every frame. Returns immediately if game running is false. Dark blue background color hashtag 1A1A2E fills entire canvas clearing previous frame. Update phase calls move player for input handling. Spawn obstacle to create enemies. Update obstacles to move and remove them. Update particles for effects. And check collisions for hit detection. Draw phase calls draw obstacles first for background layer, then draw player for main character, draw particles for effects layer, and draw score for UI overlay creating proper rendering order. Request animation frame calls game loop recursively creating 60 frames per second game loop. Spacebar event listener checks if space pressed and game not running. If true, resets obstacles array to empty, score to 0, player X to horizontal center and Y to bottom, sets game running true, clears particles array, and calls game loop to start. Initial start message draws white bold 36px text centered on canvas instructing player to press space. And there it is. A complete playable game. Smooth player movement, obstacle spawning and falling, collision detection working perfectly, particle effects on death, score tracking, and restart functionality. All in 30 minutes of coding. Let's look at what we accomplished. 150 lines of clean code. For core game mechanics implemented. A smooth 60 frames per second. And infinite replayability. Not bad for 30 minutes of work. You just built a game. Next level upgrades. Want to take this further? Here are 5 upgrades you can add right now. Power UPS that slow down time. Multiple lives with a health bar. Different obstacle types with unique behaviors. A high score system with local storage. Sound effects and background music. Each of these takes 1015 minutes to implement. Key takeaways from this build. First, start simple and iterate. We built core gameplay first, then added polish. Second, time box your projects. 30-minute constraints force you to focus on what matters. Third, steal shamelessly. Every game mechanic has been done before, learn from others. Fourth, finish things. A complete simple game beats an incomplete complex one. Fifth, game feel matters. Those particles took 5 minutes but made it feel 10 times better. Quote, the best way to learn coding isn't by reading, it's by building. Build fast, build often, and don't be afraid to make messy code. You can always refactor later. Brian Codeforge. Your challenge. Here's your challenge. Take this code, customize it, and make it your own. Change the colors, adjust the difficulty, add new features. Then drop a screenshot in the comments. I want to see what you build. The starter code is linked in the description. No excuses. You have everything you need. Next video. Build a chat app in 45 minutes. Thanks for coding with me today. Remember, the only difference between you and a professional developer is time and practice. Keep building, keep learning, and I'll see you in the next video. Now go code something amazing.